Hey, welcome back to Math with Patrick. Today is August 23rd, and we're solving problem number 235 from the Daily Epsilon calendar. And we should show why the answer should be 23 today, because we're solving for x, and this x should match today's date. So I see a somewhat standard, just one variable equation. We have x plus the square root of 6 times x minus 134. And this is supposed to be equal to 25 for today. And so I have a few thoughts already about how to solve this. One is that sometimes solving things with square roots is a little bit difficult. And you can always undo a square root by squaring things. So that's something that's kind of going on in my head right now. And the other one is just that I know that you can't square root negative numbers as long as you're working in the real number system, which I assume we are. And so this number right here, if x is kind of small, is negative. If we plug in 0 for x, I know that we aren't really supposed to take the square root of negative 134. So another thing I'm thinking of is when is this actually positive, or I guess non-negative, so that I am allowed to take the square root. I guess for starters, I just wanted to talk about why it can't be negative underneath. Just kind of by definition, a square root basically says find some number out there where that number times itself gives you the thing underneath the square root sign. And so for this case, the square root of 16 is 4, because if we think about, 4 times 4, that gives us 16. And this idea is the exact same one as taking the square root, just kind of in reverse almost. So if we start thinking about what number could we get when we have a negative number underneath that square root sign, we could think, well, okay, if I try to just use 4 again, I'm going to get positive 16. And if you try to get a little crafty here and use a negative number like negative 4, you're still going to get positive 16. So in the real number system, there are no numbers that you can multiply by itself to get a negative. So what I want to do right now is figure out what value of x causes this to become 0, because that will help inform me when this number could actually be square rootable. So 6x minus 134 equals 0, specifically when 6x equals 134. And we could just divide both sides by 6 to get some kind of representation for x. And I guess we could do a little bit of long division just to see what that number is. 6 goes into 13 twice, and then 6 goes into 14 twice again. And then the remainder looks like is 2. And then you can always add on your remainder divided by your divisor onto your quotient. And so ultimately our answer here is 22 and 2/6, or I guess just 22 1/3. So this is the very smallest number for x that I could even consider putting underneath that square root sign, because it's 22 1/3 that causes this to become 0. And of course, given the constraints of our calendar, we know that the answer must be some kind of natural number. It must be a counting number, 1, 2, 3, 4, 5, because the answer is always the same thing as the same date as today. So I can't plug in 22 1/3 because that's not a valid input for these calendar problems. The next best number to check is just 23, which happens to be the answer. So we could just guess and check it. 23 plus root, and then 6 times 23 minus 134. We're going to check if this is equal to 25 or not. We could just do this computation here. 6 times 23. We're going to get 18 plus 120. So that's 138. And then from here, I can kind of tell that it is indeed equal to 25, because this is what the 138, subtracting away the 134 gives us 4. And then the square root of 4 is just 2. And then 23 plus 2 is just 25. So it all checks out. Essentially, the smallest natural number that we could even attempt for this problem happened to be the answer. But I'm usually not satisfied with like guess and check answers. I at least wanted to show that you could just kind of think through it logically about like what numbers are we even allowed to plug in, and then you could just guess a number and come across the right answer. I am curious to see what would happen if I tried squaring both sides. And before I do, I think it'd be best to subtract the x to the other side, do a little algebra step first before we square both sides, because I think that would make my arithmetic um, or algebra rather easier. So I could just subtract the x from both sides, and this is the equation I get. Squaring both sides yields 6x minus 134 is equal to whatever this squared is. I can multiply through everything. 25 times 25 is 625. Whenever you're multiplying binomials, you need twice the product of these two terms, so minus 50x. And then it's this times this, which is just an x squared at the end. And before we keep going, I want to put a little note in here where when you're working with square roots and you're either square rooting or squaring stuff to both sides with algebra steps, you may sometimes come across extraneous solutions. For example, if I do a simpler equation and I say something like root x is equal to, say, 2, and then I decide to square both sides, I would get x is equal to 4. And I guess that is all fine and dandy because 4 is the only number that's allowed to go there. But I was thinking, like, I don't know, what if secretly this number on like the right side of the equation was accidentally a negative number? And right now we know that this cannot be the case. I can't square root things and get negative numbers either, just because I can't find any number out there where once I square root it, I get a negative, right? Because it always returns positive numbers. And if I try putting in a negative number under there to like try to get a negative result, this again is kind of breaking those rules of what the real numbers can do. So anyways, if I start with some kind of equality that's a little bit questionable, because I don't know when I can get a negative number out of a square root of a real number, if I decide to square both sides, square, these cancel out, I get a 4 on the left side, it seems like I'm getting an answer. It seems like I'm allowed to say, yeah, x is 4. But then if I go back to the original condition, which was this, and I try plugging that 4 back in, this is not true. The square root of 4 is just positive 2. So all of this is to say that if you are the one deciding to square things, you might accidentally be producing an extraneous solution, one that doesn't actually solve the original initial condition. So just something to keep in mind before we keep going. I want to solve this quadratic. I want to set things equal to 0. That's usually the best way to do this. So I'll go minus x and then plus 134. That's going to cancel out these terms and get a 0. I need to keep my equation balanced, so I'll do a minus 6x here and a plus 134 there. I also want to rearrange my terms so I have it written in standard form. That just means the higher exponents come first on that x. This is just because I'm more used to seeing equations this way. And this is going to be 759. With this quadratic, I could factor it. I was actually talking about factoring in yesterday's video. I'm trying to find two numbers that multiply to this and add to that. And just because we know that the answer today is 23, I do know that one of these numbers is going to be a minus 23 right here. And then I guess that just forces the other number to be a minus 33, right? I'm adding this and this together to get negative 56. Just to be sure, I also want to multiply these numbers together. I should get 759, but I don't quite see it just yet. 3 times 3 is 9. 3 times the other 3 is still 9. Placeholder 0 for the 20. And then 2 times both of these 3's would just be 6's. And then we do get 957. Okay, cool. So this factoring does work. And at least this algebra method of squaring both sides, finding the quadratic, setting it equal to 0, we do get two solutions, x equals 23 and x equals 33. And here is where we would need to go back and double check and see, do these answers actually make sense for our initial equation? 23 does, because we already checked that earlier. And let's just see what happens if we accidentally pretend that 33 is the right answer. We might see something silly come up here. So 33 plus, and then 6 times 33, that's going to be 180 plus 18, so 198. We're going to subtract that 134, and so we'd end up getting 4 there, and then 6 there, so 64. So plugging in the 33 gives us the square root of 64 right here, which is just the number 8. But then now we're getting an equation that's kind of nonsensical, right? 33 plus 8 is not 25. Like, this is already bigger than 25, so it doesn't make sense. However, 33 minus 8 actually is 25. And herein is kind of that extraneous solution happening again, kind of with that idea of like that 4 versus negative 4. This algebra step in squaring both sides actually allowed this value right here to either be 8 or negative 8. But we both know that you can't square root something and get a negative number out of it. However, my algebra steps did kind of allow that when I was doing this solution. So the reason why this number right here turned out to be a positive 8 is because in my algebra steps, I allowed it to also be a negative 8. And this would have been a totally fine solution if it were allowed to be negative 8. So there's two ways to solve this. You could either just kind of guess and check, follow the logic behind the operations, find the 23 that way. I think the more general and widely used solution would be this one, where you square both sides and solve for x. Although, always remember, you should check your answer and make sure that they work or don't work. So x is 23. We're all done for today, and Quill and I will see you in the next video. All right, bye.